Can you see the whiteboard? Can you see the whiteboard?
Yes, ma'am, I can.
Okay. Let's
I'm
start.
just switching off the mic so there won't be any background noise, ma'am. I'll turn it on once if you ask me any question or something.
Pardon?
I'm
Okay,
just
okay. You
turning the
want to
mic
switch?
off so
Yeah,
this.
yeah, sure, sure, sure.
Yeah.
If you means cannot hear, not got anything, then you can type me on WhatsApp. Okay?
Yeah, ma'am. Because there's a background noise, I don't want that to be disturbing
Sure,
the class. That's right.
sure, sure. You can even write me on chat box also of the class. I'll
Done, ma'am.
regularly check that so that
Okay,
you can
ma'am.
understand everything well.
Okay, ma'am. Thank you.
Sigma notation, next topic. What it means in summation this we say this, okay? Summation means sum of all values, okay? This we say this summation means sum of all values. Okay, so what it means, so if we have like summation xi, okay, and I is equal to 1 to up to n, that means we are adding n terms, like when we put and I is equal to, you have 1 to up to n, that means like we are adding x1 x2 plus up to xn, okay? Summation xi where I is equal to 1 to m up to n means we are adding n terms, okay? Sum of n terms, that means. Got it? Got it? Okay, all right, you can type here also.
Yes, ma'am. Yes, ma'am. I got it.
Okay, all right, you can type here, I'll see that. So let us do now properties of this sigma notation. Let us do. Like if we have like summation xi I is equal to 1 to up to n plus summation zi. Here also we have I is equal to 1 to up to n. Then we can combine them as summation I is equal to 1 to up to n xi plus zi. We can write them as, okay? And if we multiply by any like constant value, here c is any constant, when we multiply like terms by this constant, then obviously we'll get the sum in the same way, like we are multiplying c with each term, when obviously we can take common outside, okay? Then we can represent as I is equal to 1 to up to n and summation xi, or there, yeah, summation xi, okay? Like we have x1 is equal to 2, x2 is equal to 3, x3 is equal to 4. We have three terms, okay? Here we are taking I is equal to 1 2 3 only, okay? And we need to find sum of all values. So we have summation xi I is equal to 1 to up to 3 only. So we have 2 plus 3 plus 4, okay? And if let c is equal to 2, then c into xi, what will we have? Like summation I is equal to 1 to up to 3. Summation I is equal to 1 to up to 3 only, not n, because here n is equal to 3. So what it means we are multiplying 2 with each term. Okay, 2 with 2 plus 2 with 3 plus 2 with 4. Okay, and that is equal to, we can take 2 as a common, and we have here 2 plus 3 plus 4 here. And what is this? This is summation xi. So we can represent this in the terms of, in similar way we can represent it. Are you getting? Are you getting? Are you getting this
Yes, ma'am. I
step?
am
Or shall
getting.
I?
Yes, yes,
Okay.
yes. I
Okay.
am
All
getting it.
right. Yeah. So we can represent this when we multiply any constant value with xi, and where I is equal to 1 to n, that will equal to that constant value, and just multiply the summation xi. But like next property we have, this is third, this is second, and this is first one, and let us learn the third one. Means when we have product of like I is equal to 1 to up to n, xi into zi, this node will equal to summation I is equal to 1 to up to n into xi, and into I is equal to 1 to this and zi. We can verify this by using real, means by using values. Okay, how? Like let x summation xi, or xi let us denote. How? Like we have two sequence, like we have 2 and 4, 5, 6, 7. We have three these values. Okay, then and another one xi we are using, and here I is equal to 1, 2, 3, 4, and 5 here. Okay, and similarly we are using here zi is equal to 1, 3, 4, 8, 9. Okay, we have these values. So obviously we'll get xi into zi. Just multiply corresponding terms, multiply these. Okay, corresponding values, let us multiply. So xi zi will get 2 into 1 plus 4 into 3 plus 5 into 4 plus 6 into 8 plus 7 into 9. This summation. Okay. Or if we are finding this in the form of sequence, so just put comma, then later when we add, then we'll use some symbol of addition. Okay, we have still the sequence only. Okay, are you getting this? This is step, are you getting? Later we'll find. Now summation, let us find summation xi, and I is equal to obviously 1 to up to 5. Okay, for each. So let us find, we have value of x 2, 4, 5, 6, 7. 2 plus 4 plus 5 plus 6 plus 7. We have only these values. So let us find it. Uh, so we have 24. Okay. Now let us find summation I is equal to 1 to up to 5 2yi is equal to, let us add all values of sorry zi, not yi, sorry, we are doing for zi, not y, is equal to 13489, 134 plus 8 plus 9. So 1 plus 3 plus 4 plus 8 plus 9. What we have? 29. Oh, no, 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 sorry, my mistake. Uh, 8 plus 8, 16. 16 plus 25. 25 we have. And summation xy and zi, let us find what we have here. Here 2, 12, 20, 48, and 63. Let us add them. So we have 2 plus 12 plus 20 plus 48 plus 63. Let us add them. 2 plus 12 plus 20 plus 48 plus 63. This is 145. Okay. Now we need to verify that this, okay, this is not equal. We need to verify. Let us verify. Let us take left. We have left hand side, this left hand side we have summation xi into zi. We have already, okay, LHS. Summation xi is sorry, I is equal to 1 to up to 5 xi and zi. We have 145. Now let us find RHS. What is it? Like summation xi into I is equal to 1 to up to sorry 5 only, because we have only 5 values, and into summation I is equal to 1 to up to 5 and zi. So we have 24 into 25. What we have? Let us find it. We have 600. Okay. Obviously, they are not equal. That is why we have verified this rule. Okay. Are you
Okay.
getting? Yeah.
Yes, ma'am.
Let us do the next. Now let us know pi notation. What it means. Let us know now pi notation. Just a second. Give me one moment. One moment. Okay. So, the sigma notation means sigma means sum of all values, and pi notation in short you can understand product of all values. Okay.
Okay, ma'am.
So pi, this is pi notation where I is equal to 1 to up to n. Xi means we are multiplying n values like x1, x2, x3 and up to xn. Okay. Similarly, this is first property, and now let us do second. When we multiply any or like value, this constant value with terms, what will we get? Pi I is equal to 1 to up to n. Cxi is equal to c to the power n, and pi I is equal to 1 to up to n and xi. What it mean? uh, Means pi notation, product of all value. Let us do for this. Okay, what it mean? We'll get the both thing here. Means we have here pi means pi xi also. So we'll understand these both together. Okay, are you getting?
Yes, ma'am.
Okay, so let us have some values like xi. Let us take we have 2, 4, 6, 8, 10. Okay, so let us find pi I is equal to 1 to up to only 5 because we have 5 values. Okay, here n is equal to 5. Okay, so now let us find I is equal to pi I is equal to 1 to up to 5. That is equal to, just multiply this value, 2 into 4 into 6 into 8 into 10. So let us multiply them. Then we can find 2 into 2 into 4 into 6 into 8 into 10. So we have here obviously the product of all these values. We have 3840. If we multiply each term by a constant, like we multiply this by 2 xi. What it means? Multiply each term by 2. Now let us find its pi value. So pi I is equal to 1 to up to 5, and we are finding for 2xi. So just multiply like 2 into 2, 2 into 4, 2 into 6, 2 into 8, 2 into 10. So we are multiplying this 2. How many times? 5 times. Okay. So we can write it as we can write as 2 to the power 5. We can take like as, because we are multiplying this 2 5 times. Okay. So let us write here 2 to the power 5, and we have rest of here 2, 4, 6, 8, and 10 we left with this. So just multiply 2 into 4 into 6 into 8 into 10. Okay. So we can express it as pi 1 to 5 we have, and 2 xi here. C is equal to 2. We are taking constant value. So this is equal to just 2 to the power 5. Okay. And summation xi. Sorry, not summation, pi. Sorry, my mistake. Pi xi. And this is 5 and xi. You know why? Because this is the value of summation. Sorry, not pi xi. This is not summation because we are multiplying. So obviously we'll use here pi notation. So this is equal to pi xi. 2 to the power 5 we are taking, and we have verified this formula, or you can say property. This one. Got it? Got it? Or want to ask anything?
Yes, ma'am. I understood.
Okay. 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 So now let's do the next. Okay, next is we have like pi I is equal to 1 to up to n 1 plus ri. How can we express this? So next formula, or you can say property of this pi notation, I is equal to 1 to up to n and 1 plus ri. What it means we are multiplying this r n times. 1 plus r n times we are multiplying. We are taking here r1, r2 means second term, third term, until to 1 plus rn. Okay, another term. So, how can we find the geometric mean? Okay, so geometric mean is just nth root of this. By using this formula, we can find as you have in your book. So, geometric mean is, in short, we write GM is equal to square root of pi I is equal to 1 to up to n and 1 plus r I. Okay, this is formula, and this is not square root. We are taking here nth root, because square root when we take we have only two terms. Okay, geometric between mean between or like then we use this only square root, and here we have n terms, so that is why we'll find here nth root. Okay.
Yes, ma'am. Yes, ma'am.
Now what we have, okay, function of more than one variable. How can we define it? And then we'll do differential calculus after that. So function of more than one variable. Next topic we have function. First, you know very well in one variable y is equal to fx. Okay, so we say y is the function of x. Why? Because if fx is equal to like 2x or x square anything, then we can express y is equal to 2x. So obviously value of y depend on x. We put value of x, then we can find corresponding value of y. Like if we put x is equal to 5, then obviously we'll get y is equal to 10. Are you getting?
Yes, ma'am.
Yeah, so in this way we can define function in one variable. Now we have function of more than one variable. Next topic. So y the function of two variables, or we can have more than one. We can have of two variables, or three variables, or n variables also. So here we are using of two variable. Like we are taking first constant term, then v1 x1 plus v2 x2. We have two variables here, x1, x2. Okay, and this a, b1 and b2 are constant. Means not only we can represent in this only addition form, we can have like subtraction, multiplication, and division. Only this involve like more than one variable. Okay, means if we have like y is equal to 2x1 x2, then this is also function of two variables because its value depend on these both x1 and x2. Okay, so shall we do now differential? Shall we start?
Your wish, ma'am.
Okay, now let us
Is
start
it like
differential.
a huge topic or?
Let me check because it's huge obviously, but I'm just checking which function you have in here in differentiation.
Okay.
Okay, they have given to you like polynomial and okay, not much,
Okay.
but we cannot finish today only. Let just start it. Okay, let's start
Yes.
differentiation. What it mean? First of all, let us understand. Like we have y is equal to fx. Y is the function of x. Obviously, value of y depend on x. Then if we change any change in y, then obviously we'll get corresponding change in if we change in x, then obviously we'll get corresponding change in y also. So we can differentiation is just rate of change of y with respect to x, means because of change of x we'll get a change in y, then the rate of change of y with respect to x means because of x, or you can say because of change in x, that is called differentiation. Okay,
Yes, ma'am.
so this is meaning of differentiation, and we denote by using symbol dy over dx or y dash, or by using y1 or f dash also. Okay, are derivatives, means result of the result after get the differentiation we say them derivatives. Okay, are derivative symbols. Okay, with respect to or like symbols of y with respect to x. Okay, so first of all let us learn the formula. They are using only a single for polynomial only. Yeah, because you have only for polynomial here in your syllabus.
Okay, ma'am.
Differentiation is very broad, means this has like trigonometrical function, logarithmic function, exponential function. So you have only one, that is polynomial function, means just in power of variable only you
Uh,
have. So that's good. So we have only like three formulas here because we have lots of formulas, but according to your syllabus, you have only three formulas main.
okay, ma'am.
first, this is a symbol of differentiation, okay? D over
Yeah.
dx of any constant value. Means
Okay.
differentiation means rate of change. But in
Okay.
constant, there is no change. So differentiation of constant is zero. But in
Yeah.
constant, there is no change. And the differentiation meaning is only about change, rate of change
Okay.
of y with respect to x. So if we differentiate any constant, then we'll get zero. And
Okay.
differentiation with respect to x of x, that is one. Means we have x in numerator as well as in denominator, then we'll get
I
here
don't know.
one.
That's true. Okay.
And if we have like any constant value along with x, then first of all write this outside and then differentiate x. So obviously is equal to 1. So just multiply k into 1, obviously you will get k. Okay.
Okay.
So when you have any constant value along with x, then you can write just value, because derivative of x or differentiation of x is 1. Got it?
Okay. Yeah.
The next or main formula, most important. Uh, if you have power of variable, then how can you differentiate? This is about that. So just write power first and just subtract 1 from its power. This is differentiation of x to the power n. Okay. So let us do one example for each question. Okay. So if
Okay.
we have y is equal to 5. Now let us find dy over dx derivative or just differentiated. D upon dx of 5. You know 5 is constant, so its differentiation is 0. Got it?
Excellent.
Similarly, now let us, this is the for, I mean, this is about only x, okay? So this is example in itself. So let us do this one and this one. So we need to take the next step, whiteboard, because we have only 12 pages and we have completed
Okay,
it.
man.
Let me
Done.
save it. And you can see this in study material section, each
Okay.
whiteboard. Um, and you know, you have also recorded lecture in recording section of this class.
Yes, ma'am.
Yeah, you can use that for revision. So now let us take next example. Y is equal to like we have 7x. Now just differentiate it dy over dx. Just write down d over dx of 7x. Write down 7 outside because this is constant along with x. Write as. So differentiation of with respect to of x with respect to x is 1. So we'll have here 7. Or you can write in single step. Okay, because by using this formula, like when we have constant along with x, then we can write directly constant. Okay, now you got it.
Yes. Yes, ma'am.
Next, let us take next example when we have x to the power something. Y is equal to x to the power 9. Now let us differentiate it. So dy over dx is equal to d over dx of x to the power 9. So let us write here 9. Means just write the power here and just subtract
Okay.
1 from its power. So we have
Okay.
9 into x to the power 8. So this is differentiation of x to the power 9, which is 9 into 8, x to the power
Uh,
8. Okay, you got it now?
yes, ma'am.
So these are the fundamentals of differentiation. Now we have product rule and quotient rule of the derivative. Let us learn. Now let us know the product rule. Like we have y is equal to product of two function like fx into gx. Now let us find its derivative. It is dy over dx. First function write as such, then find derivative of second function gx. Now write down second function gx and into derivative of first function. This is product rule when we have product of two functions. Okay, so if we have product of two function, then write down first, then derivative of second, plus second into derivative of first. So this is product rule. Got it? Or we can write it as, derivative can be defined as like like we are not differentiating this just before of d over dx. Okay, so write down as such. We are differentiating this gx. So derivative of gx is g dash x because we denote differentiation by using dash also. And here write down gx, and here f dash x means derivative of fx. Okay, so this is product rule. Now let us understand this product rule. You got it? You got this rule? Or shall I explain you again?
I got it, ma'am.
Okay. So now let us take an example to understand this one. Like y is equal to x plus 1 into x cube plus 2x plus 5. We need to differentiate it. We have product of two function. Obviously, this is first function and this is second function. So let us differentiate it to find dy over. So dy over dx is equal to write down first function into derivative of second function. Derivative means we are doing we are differentiating a function, then that result is said to be derivative. Now write down here second function and derivative of first function. So write down first function as such because we are differentiating just one. So here means we are differentiating d over dx of x cube plus write down 2 outside because this is constant d over dx of x and plus d over dx of 5 because here we are writing y outside because we have x also. Okay, so here we have only 5, so we need to write here 5. So now write down as such this x cube plus 2x plus 5 and derivative of just multiply on take derivative of x plus derivative of 1. This we are doing for that. So write down x plus 1 and derivative of x cube we have 3x square obviously into derivative this will become 1 only and derivative of 5 is 0. 5 is constant, that's why. Now let us take x cube plus 2x plus 5 and derivative of x this is 1 and derivative of 1 is 0. So 1 plus 0. Okay. So now let us simplify this and write on the next page. So this is x plus 1 and 3x square plus 2 only, okay? And here we will write the same and here only 1 because we multiply 1 with this, so we'll get the same. Are you getting?
Yeah, I'm getting it, ma'am.
Okay. So dy over dx is x plus 1 and we have here 3x square plus 2 only, and plus x cube plus 2x plus 5 only, and this is the required answer. Okay, so this is the example of product rule. So let us do in the next class quotient rule, higher order derivative, and partial means differentiation. Okay, and then
Okay.
we'll finish the differentiation.
Okay.
Yeah.
Should we have the class tomorrow or Saturday, ma'am?
No, no, not tomorrow. On Saturday. Okay.
Okay.
Yeah.
Done.
We'll finish differentiation. Okay, entire that day. Because today lots of time is wasted.
Okay.
So we'll do for 1 hour next in next class. So we'll finish entire derivative
Yeah.
differentiation. Okay.